All right, day 11, parabolas. I'm just going to give you some notes here just about the parabolas and how to set up the equations on the standard form, and then we'll talk about graphing them and writing the equations a little bit when we get into class on Monday. But just looking at the parabolas here, I'll give you a definition for parabola. It's a set of points, and I've tried to simplify the definition a little bit. It's a set of points that are equal distant from a fixed point, which is called the focus, and a specific line, which is called the directrix. And so when we do a parabola, we've got to find some things. We've got to find our vertex, which our vertex will always be our maximum or minimum if it's opening up or down. We're also going to talk about parabolas that open left and right too. But for example, here in this one, we have a parabola that's opening up. This is my vertex point right here. And then with a parabola, you also have what's called a focus point. And then we also have a directrix, and then we're also going to find the axis of symmetry. So what I want to do is I want to take this picture of the parabola and I want to label all those things for you. So here we have a parabola with a vertex, looks like at 3, 3 is my vertex point. The focus point, when you start looking at these, your focus point is going to be inside of your parabola. So if your parabola is opening up, then your focus point is going to be above the vertex. If my parabola was opening down, my focus point would be below my vertex, but it's going to be inside of the parabola. So let's just say, for example, here that I had a focus point that was sitting right here. We're going to call that the focus. Okay? Well, it turns out that your focal point and your directrix are the same distance from any point on this parabola. So a good point to always use as a point of reference is the vertex. So if you look here, I went 2 units up to my focus point here. So what that means is my directrix has to be 2 units down. Now the focus is a point. The directrix is a line. So in this case, my directrix is a horizontal line going in that direction. So this is my directrix. Okay? So if I was actually doing this as a problem, I would have my vertex, which would be 3, 3, and then my focal point would also be a point. It's at 3, 5, and my directrix would be a line at y equals 1. But here again, if you notice, our definition said that all the points on here are an equal distance from this point and this line. So all of my points on here, I am 2 units away here from my vertex, I'm 2 units away from my directrix. If I picked another point, let's say over here, it would be the same distance from that focal point as it would be to the directrix. And it may not look like it on my graph, but that is the idea with a parabola. Okay? So those are the 2 main things. The other thing that I do want to label is what's called the axis of symmetry. The axis of symmetry actually runs right through the middle of the parabola. It goes through the focal point, it goes through the vertex, and it's perpendicular to my directrix. So this is my axis of symmetry. And in this case, it's a vertical line, so that would be labeled as x equals, and it goes through 3. So that is x equals 3 for the example that I have up here. Now, one other thing that I do want to label on here is the distance from the focal point to the vertex or from the vertex to the directrix. This has to be the same distance. And what we do is we label that distance with a variable when we're talking about parabolas. We actually label this distance right here. We call that P. And that's going to be important when we go to write our equations and when we look at our standard form for our parabolas. So we're going to make sure that we want to take that into account. So that's kind of a picture of what you're looking at to give you an idea. Now let me just show you what the standard forms look like for parabolas. All right, so let's take a look at the standard forms here. And then I'll show you how to find all that information with the standard forms. So this is what the standard form for a parabola looks like. It's x minus h squared equals 4p y minus k. Now notice this part's not squared. With a parabola, you only have one squared in the problem, unlike what we did with circles. But notice we still have the h and the k, and then also notice that this p has popped up right there. Okay, so when we're doing these, this would be one that opens up or down. This is what the standard form will look like. Our vertex here is just like what we did today with the circles. We're going to take opposite h, opposite k. Remember we talked about h and k, really you're doing it's really the formula says h comma k, but just the opposite kind of helps us to remember that. Now when we do our focal point, if we'll notice for one that opens vertically here, our focal point, notice that the x value stays the same. It's the y value that's changing. So when we're doing our focal point here, we're going to keep our x coordinate, opposite of h, the same, but then what we're going to do for our y coordinate, which is opposite of k, we're going to add p to it, not h. Add p to it. Okay? So we're going to take whatever this p value is, and we're going to add it to k. So up here in my example, my vertex was 3, 3, and then notice that my focal point is 3, 5, and p in this problem turned out to be 2, because that was my distance there. Okay? The axis of symmetry, that actually turns out to be x equals, and we just do, opposite of h, whatever my h is there. And then my directrix, it is a line, and it's y equals, but in this time, instead of adding p, we subtract p. So if you go back up here to the top and you look here, my vertex was 3, 3, 3. So I had 3. If I subtract 2, I'm now at 1, which is what my directrix is. So that's our formula for the directrix there. Okay? Now, this is the standard form for one that opens left or right. Okay? And parabolas that open left or right, it might look like that. That's a parabola that's opening to the right. But what happens here is the vertex is still going to be the same. We're still going to do opposite h, opposite k. You have to be careful though, because now the h is over here, because it starts with y minus k squared, so don't get your h's and k's mixed up. H always goes with x, k always goes with y. But now our focal point is going to change. Instead of adding it to my y value, like I did over here, so it's vertical, I added it to y. Since it's horizontal, I'm going to add it to my x coordinate. So opposite of h plus p, then we go opposite of k. And then here, my axis of symmetry is going to change. Instead of being x equals, it's going to be y equals. And it's not going to be the opposite of h. It's actually going to be my k. All right? And then here, we're going to flip our directrix also. Instead of being k minus p, we're now going to do our h minus p. And here again, remember, this is really just hk, but I always just say opposite just because then it keeps us in the framework of, make sure we take the opposite of these symbols when we see the minuses in there. If it's a plus, we make it a minus. If it's a minus, we make it a plus. So that's your standard forms. That's what a parabola is going to look like. We'll talk more about how to graph one of these in class, and I'll also talk to you about how to write the equations. And it's really important to understand what P is when we're writing the equations, because what I'm going to give you is the focus and directrix, and then you're going to have to write the equation there. The key to all this is understanding this diagram, that the focus and the directrix are the same distance away from that vertex. That's going to be key for us.